Okay, let's look at inverse functions, right? So inverse function is basically a reverse process of original function, right? Let's visualize in a diagram. Right, let's say you have a function which looks like this. 1 maps to B, 2 maps to C, and 3 maps to A. Right? Then inverse function is simply just can be obtained by reversing the direction of the arrows. So you can see that the B is going to be mapped to back to 1. So maybe I should. And the C is mapped back to 2. And A is mapped back to 3. All right. So so this is the called the F inverse, right? Inverse function. All right. Then you can see that since we reverse the direction of the arrows, so this used to be the domain of F. So I'll write the D of F. Right. This was the range of F in this case. All right. Then since we reverse the direction of the arrow, all right, this becomes the range of F inverse. All right. And this becomes the domain of F inverse. Right. So basically everything is kind of flipped. All right. And another way to look at it is that since a reverse process of the original function, let's try to find the inverse function of this given function. F of x equals 2x minus 3, right? Then try to think about what this function does, right? So let's write it in English. All right, so what it does is takes the x value, and the first thing it does is multiply by 2. So it's a multiply by 2. All right, then after that you subtract 3. So just say subtract 3. Right? So this is what function f does, right? Then think about try to reverse this process or undoing what's been done. All right. So So what we need to do is just like undoing socks and shoe. If you put on a sock and put on a shoe, you have to undo the shoe first, then undo the socks. All right, sock. All right, so let's undo subtract 3. So that'll be easy, right? So in order to undo that, we can just add 3. All right, then we need to undo multiplication by 2, so we can simply divide by 2. All right, so we can actually find the formula which does exactly this. All right, so this is, I'm gonna call it F inverse of x. All right, so first we take the x value and add 3 to it. So we have plus 3. All right, then divide the result by 2. So divide the whole thing by 2. All right, this is actually the correct formula for the inverse function. All right, so here's a note. Since inverse function is a reverse process of the original function, when you compose f and f inverse, then it basically kind of cancel each other out, because you apply f inverse and you apply its reverse process, so they cancel each other out, and what you end up getting is just x. Right? And you can compose the other way around, so you apply f first, then apply F inverse. Alright, just like before, they cancel each other out because they are reverse process of each other. You just get X back. Right? So this is the inverse property. Alright, and well, remark is that seems like you can always change the direction of the arrow, but the thing is not all functions have their inverses. All right, here's an example. All right, let's look at this function. 1 maps to A, 2 maps to B, and the 3 maps to B. All right, so let's try to reverse the direction of the arrow. So this guy goes back to 1, B back to 2, and B also back to 3. All right, and what's wrong with this guy? All right, so you can see that B is actually mapped to 2 and 3 at the same time. So B is actually a troublemaker, which violates the definition of the function. So you can see that this is actually, we thought that this would be an inverse function, but this is not, since it's called a function, but this is not a function, right? So there's no inverse for this function. Right? So what caused the problem is that here, if you have two different element in the domain is actually mapped to the same element in the codomain. So that's the problem. So we have to eliminate that. So there's a function called the one-to-one function. So we just add the extra condition. All right? So function is called the one-to-one if 2x by x1 is different from x2, then corresponding y value, f of x1 and f of x2, are different. All right. There's an easy way to check a one-to-one function if you have the graphs of the function. All right. So let's look at the following two graphs. All right. And this is called the horizontal line test. A function is one-to-one if no horizontal lines intersect its graph more than once. All right. So here's a graph, and you can easily see that here. If you put a horizontal line right here, there will be 1, 2, 3. So there are more than one intersection points. Therefore, this is the graph. This is not one-to-one function. So this is not one-to-one since it fails the horizontal line test. All right. About this one, if no matter where you draw your horizontal line here, and we can only intersect once. All right, so therefore it passes the horizontal line test. So this is a graph of a one-to-one function. All right, so it's fairly easy to check graphically. All right, note that remember we talked about the vertical line test. All right, vertical line test. All right, vertical line test is for checking to see if the curve is the graph of a function. So it's checking for function, right? And a horizontal line test is checking for one-to-one function, right? So that's the difference between horizontal line test and a vertical line test. All right. So this is the concept of inverse functions. I hope that this was clear.